Welcome to Brian's Logic Lab. This is the very first video for my new YouTube channel that I'm just started. So there's a learning curve here, and this is sort of a unique video of us. I'm repairing a mask in Glo. It's for skincare, but I don't want us to get too focused on the actual item that I'm repairing, but maybe we can look and see if there's some things we can learn from the actual repair. One of the tools in the video that I use is a sonic saber. It's basically an X-Acto knife. That's an ultrasonic X-Acto knife, so I think it runs about 40 kilohertz. If you've never heard of one or never seen one, I show it in the video. It's a tool that it's not a bad tool to have in your arsenal. It's not your first go-to. You know, there's other techniques typically when you're trying to take a sealed device apart. You know, maybe heat, maybe a solvent, other things, but in some cases there's really no other way to get it apart because it's not made to take apart. Okay, so if you like this type of content after you've watched it, you know, subscribe to the channel, comment. I'm here to learn and take constructive feedback as well. So if there's things that, you know, as we go along this we go down this path for this learning journey, I want to learn as well. So we'll share together, we'll learn together. So you'll see in the video that, you know, I'm going to be in different clothes today than I was when the video starts, because this was recorded over several days and spliced together. So at this point, let's go ahead and jump into the video, and we'll go through the repair and see what we can learn together. Today we're going to work on it's called a mask in Glo. It's got a battery and controller here. It's a anti-aging mask, and it's for a friend at work. The problem is this little battery and controller, it's not working. It's not holding a charge is what I believe is happening. The complaint is that it will run for a couple minutes and then it'll turn off. I think it's supposed to run for like a half hour. So I suspect there's a problem in here, which this is a sealed device, which is like a lot of things nowadays. You know, it'd be nice if it just had a couple screws here that you could take out and take it apart, but that's sort of a thing of the past, I guess. So today we're going to look at first trying to get in this and then repair it, but you know, we got to get into it with as little as damage as possible. So let's go ahead and jump into it and see what we can do. This is the sonic saber. So let's see if we can try to open it with this. So what I'm going to do here is I'm going to use my microscope and so we can see close up sort of what's happening. Cut it apart here and clean the edges up a little bit. We'll clean them up a little bit more before we put it back together. So let's see what we got in here. So here's the USB-C charging port for charging the battery, and here's the output that goes to the mask, the USB output here. Here's the battery. We can see what kind we got here. Zoom in a little bit, put a little light here on it. Hopefully we can see this. Looks like it's the 18650. Very, very common battery. 18650, 3.7 volt, 2600 milliamp hours, 9.62 watt hours. So 18650, that's what I expected to find in here. You see it in a lot of different devices, laptop batteries, flashlights, about anything you open up. It's got one or more of these in it, depending on what they're doing. I think even the Tesla has these in it. It's just got a lot of them in series and parallel to get the need, to meet the need that they have for the vehicles. So I think at this point we will unsolder this battery out of here, and then just for a verification, we'll take it and put it on the battery analyzer and just see what kind of capacity that it has, and then we'll find another 18650 and get it we'll weld it. We'll weld the tabs on it, and then we'll resolder it. But it'll be easier to work with once we unsolder it from the board. So I think let's do that first. All right, we'll just switch over to the microscope here. Give us all a better view of what we're seeing here. So obviously we can see our red wires over here on the left and our white wires on the right. So let's just unsolder it right quick. Grab a pair of tweezers here. Let's just heat this up. Take this wire loose. Let's get the white wire. Let's get back in the frame. Actually, let's turn it around so I can get away from the plastic. I'm right-handed, so we'll turn it this way. We'll reach in here with our tweezers. We'll just grab the white wire. Okay, so we now have the battery disconnected here, so we'll move this out of the way for now. So here's the battery. So you can see they have a little protective end here to cover the positive end of the battery, and something similar here on this end to protect the negative end. So we'll take this little sleeve off here. Okay, here's a little circuit board and stuff under here, and we'll keep all that for the new battery. So I'm going to reuse these wires and all, and you can see right here, there's where it's we'll save that as well. Here's where it's welded to the battery. And then this one connects down here to the negative side to connect to this circuit board here. So what we'll do here is we'll take off this negative side, give us a little more room to work with. Keep these little sticky protectors and reuse them. Okay. Let me get a little pair of pliers here. Okay. A little pair of wire cutters here and trim this off flat again. There we go. Perfect. Come around, we'll do the same thing to this side. Gotta be careful up here, you know, this is the positive portion here. That's why they got this green ring on here, because you know, all this part of the battery and all this, and the bottom's negative. So if you're doing any prying up in here, if you short between here and here, you know, you're gonna, I think this battery's about shot, but it's still good practice to try to be careful here. And you zoom in a little bit. That's why I'm using plastic right now. See if I can get this off without breaking it, and I'll reuse it. If not, I've got some more of this thin metal. See if I can pull it without breaking it. Okay. All right, we got it here. So let me save this. So we just have a regular 18650 here. Like I said, it's a very common battery. Could make this process a whole lot easier if it just had a couple screws you take it apart, or just a little cover that you slide off the back of the battery, you know, like a battery cover, and you could just easily change this out. But it's not how it was designed. So let me grab my battery analyzer. We'll take a quick look just to see. This battery is supposed to be good for 2600 milliamp hour, so it's probably nowhere near that. So let me grab my analyzer and we'll take a look at it. So let's go to, we're in slot 1. So here's all the different settings. So like if I wanted to change the battery type here, You can see all the different types of batteries we could check, but we're going to leave this one on lithium ion. And the milliamps, it's supposed to be 2600, so we'll change this to 2600 milliamps. Charging current, I'm gonna leave all these other defaults. Alright, let's see what the battery does. So we'll start it here. So we'll leave it here, and we'll come back and check on it in a little bit. This will take a little while, and I'll show you the final results. Okay, this is the in-depth analysis, if you will, of the bad battery. This is slot 3. You can see it up at the top left. This is the bad battery, so it's only got 213 milliamp hour capacity. The other number that you want to consider here is the number right below it. This is the internal resistance of the battery. The lower the better. It's got 342 milliohms of resistance, which is terrible. This is the discharge curve for the bad battery, the pink one, slot 3. On the left y-axis, you can see that's the voltage. So the voltage never made it up to 4 volts like it should, or a little over. It's only about 3.7. Immediately when it a load was put on it, the orange graph is the y-axis on the right, which is the current. So the current immediately dropped off and went down well below, 2.8 right off the bat. So that's no good. So this is the battery in slot 1. That's the 2,324 milliamp hours. Got excellent internal resistance at 37 milliohms. This is the discharge curve that you would expect for a good battery. You can see that the voltage there on the yellow line on the left is start at 4.01. It curved down over a period of about an hour and a half, 96 minutes or so, and you can see that the current, the orange line, it held constant. And this is a typical response of lithium ion batteries. They hold their output and then they drop off quickly. So if you've ever used a lithium type flashlight, they'll stay bright up until the end, and then they'll go dim very quickly. So this curve here is exactly what I would expect for a good battery. Here we have the this is the old battery on the left. This is the new battery that we're going to use here on the right. So I'm going to get rid of this one for now. So first thing we want to do here is this is all bare and stuff, so we'll put a nice little sleeve on here, make it look professional, and also insulate the cell here, because we're going to install the board and stuff here shortly. So let's go ahead and put a sleeve on here. It's pretty simple. We just slide this sleeve on here, leave a little bit opening at each end, take a little hot air. Let me get my hot air station turned on. All right, here you can see we have us pretty well professional looking battery now. Okay, here's the circuit board. This one runs this thin strip of metal. It's going to go down to the negative side, and we'll spot weld it on here, and then we can spot weld the positive side. Nice and solid. Okay, it's like this side's closed up. Let's run our negative wire down the side here, and we will spot weld it on. Okay. Nice and tight here. All right. So if anybody's curious on the spot welder that I'm using, let me zoom out, we can look at it here. It's an SWM-10. This came from Amazon. I think this was maybe $40 or something on Amazon. They're not much. So it's what I used. Okay, now we just need to put these other insulators on the negative side of the battery. Put one here, and then here's the thicker one. We'll slide one more sleeve over all this. That'll help hold the ends. It'll cover this wire and give us really good protection here. So we'll leave a little bit of this sticking off each end. Something like this. Get the hot air one more time. All right, now it's just time to solder this back into the holder here. So let's go under the microscope and do that. I'm gonna put just a hair bit of flux on there to pretty that joint up a little bit. All right, now it's time to test everything. So here you see me connecting the battery to the mask, turning it on. Have a timer in the video so we can time lapse it. I started the timer. Now I'm going to let it record. I want to record it for at least a half hour just to prove the repair. So I'm just time lapsing the video so we don't have to sit through all that. So you can see we're almost at the 30-minute mark. Okay, we've reached it. I slowed the video down. I'll start it one last time just for a few seconds, just to show that would be the fourth time that it's starting up. And here I'm just stopping it, and we'll go ahead and continue with the rest of the repair. Okay, here's the finished product. You can sort of see the repair came out quite well. I mean, you can see it. You can see that it's been sealed back together, but overall, come out really well for what it is. You know, it's not made to take apart, but we successfully took it apart, put it back together, and the adhesive that I used for this is this here. It's E6000. I normally use a B7000, but the reason I picked this one, it's a pretty equivalent to the B7000, which I really like, except this one's white instead of clear. So for this, I wanted to use a white to help seal this versus having a clear sealing across here, you know, to try to, you know, make it blend back in as best I could. But and we'll just show it one more time here. I'll plug it up. It turns on, no problem. I ran it a while ago for about a half hour. It looks like every 10 minutes it turns off. So I run it 3 cycles, and I stopped there. I didn't continue. I don't know how many cycles it would take to run it completely down, but I think it looks like it's fixed to me. The complaint was it only run a couple minutes, so ran it over 30 minutes, and it still had plenty of power left in it, or charge. So I'm going to call it a success. So if you like this, please like and subscribe, and we'll find something else to work on in an upcoming video. Thank you.